Thank you so much, Dr. Shiv, for taking time out for our Vigyan Dhara next edition. As you might know, Vigyan Dhara is the Office's magazine, and we have made it a magazine from its 25th year of Office's establishment. This magazine has a special focus in the coming edition on artificial intelligence, and we also expect to cover not just the advancement in AI, but also the AI adoption in various areas. And the conversation today with you is on a special topic which we are all very excited about, AI for science and engineering. That will be the theme of the conversation. And again, thank you so much for proposing this theme. First of all, the idea came from you, which PSA recommended that we should cover it in detail. I'll start off with basics of how do we see the advancements of AI and its use in science and engineering as a whole.
Yeah. First, Chagun, thank you very much, and it's really a pleasure to be on this, and a privilege as well. So first, look, AI means different things to different people. So I think it's a good idea to just level set on what AI means today versus what it meant 5 years back or 10 years back, right? See, first, artificial intelligence, like the word says, is somehow a machine has some behavior that looks like intelligence, right? So intelligence itself is something not everybody understands what exactly it is, but a machine starts behaving or indistinguishably from what one would consider intelligence. That's the best way to think about it, right? So number one. Now in the early days of AI, it was about expert systems, then where you had data and knowledge about some things that was curated, and then you would have a query and response, right? You had ask a question, you get an answer. Okay, that was again early days, right? Then later days there were these various sorts of algorithms that culminated in chess playing challenges, and IBM famously beat the world's grandmasters and so on, right? And then there were other further expansions, but all of these were essentially linear models and other sorts of techniques that were handcrafted and what we call feature engineering done and so on. But it went for a great extent that it played the game of Jeopardy. IBM again had a thing where you had natural language type querying and so on. So there was a lot of enthusiasm. I was in IBM at that time in 2011 when the Jeopardy game was felt and so on, right? But around that time, 2010 was the birth of deep learning. Deep learning was when a class of neural networks that was already known could start modeling things more intelligently, and as you had deeper and deeper networks, you could do more modeling, right? Complex system modeling, right? See, originally think of AI as a very simple way. Suppose you have a bunch of points and you want to draw a line. This is like a regression model. So y is equal to mx plus c. You have to find out what m and c are, right? So that is the that's a basic kind of AI. So in a neural network, you don't have just a single line. You have a line and then a kink, another line, another kink, another line. So the deeper you go, you can have many different types of kinks and so on and lines, right? So then you have to learn this m and c for this, m and c for this, and so on, right? So that's a very simple way of thinking about it. So a neural network is nothing but, and the training of a neural network is learning all these parameters. This m and c is the parameters of it. Now what happened is that around the last 2 3 years when ChatGPT came on, and of course the transformer is a specific architecture that came up in 2017 from Google and so on, right? So that led to a realization that you can really learn these things much more efficiently, and you can pre-train these models. And it suddenly started having something called transfer learning properties. Transfer learning means I teach it one thing, but then it can learn another thing, right? So that is one aspect. The second part is, earlier you had to label a lot of data. Now that labeling, and you take a large corpus like Wikipedia and so on, right? And then you take a sentence, and the last word of the sentence you mask it out, and then and then you predict it, but you also know it is. So this is called a type of this thing, right? So you can rather than explicitly creating labels, you can do this masking and labeling, right? So this allowed things to proceed much faster. So the field really grew, and you could start building bigger and bigger models, right? So then it turns out that bigger models also had these emergent properties. You train it for one thing, it will start doing other things and so on, right? So that's now the combination of transfer learning, pre-training, bigger models is where we are in the ChatGPT era, right? Today. Now what is happening now is you can now do more reasoning like things, right? You can now do more other things that can help you in your research process or education process, and ultimately science itself can be more directly modeled, right. So that's the threshold where we are today.
Currently, yeah, no, thanks. That's a good foundation to start our chat with, and also thank you for taking us through the linear evolution, but also the expansion of the technological world of AI itself. Many people have this doubt, okay, AI is something that just dropped out of the sky, but that's exactly not it is, and it is through very long time. Now, given that ANRF as an agency is seen as an apex agency to do a lot of major changes in our research governance and scientific ecosystem, how do you see AI and doing science in India are coming together?
Yeah, so I will say that AI can play a very important role in the way research is done in general, right. Just like you can do education. See, education is you have a set of knowledge, right. You normally read a book and then you somehow try to model what you have learned in your mind, right. So that's what you have to somehow convert the book into your mind, okay. So that is the goal, right. So the book has knowledge, and then now AI can manipulate that knowledge and make it more interesting, right. So one of the topics we are working on is a thing called Saral, right. So you take a complex technical paper like Nature or Science paper or any other complex paper, but then how can you convert it and demystify it, make it simpler, Saral, right. And then once you make it simpler, now you can make it in your own language, you can make it in your own context. So AI has the ability to transform knowledge from one type to the other and to another type and so on to another type, till it's a point where it is more engaging and it's helpful and it educates you, okay. Now once you do that, then it allows you to democratize research, it allows you to make knowledge more accessible, it allows you to increase the speed of knowledge diffusion, right. So this allows one of our goals in ANRF is to help our top institutions go to be the world class and the topmost in the world. Similarly, we want to broaden the distribution of excellence and help more of our universities, institutions and researchers quickly get to the world class status, right. And now this allows new researchers a much more accelerated path, right. They can build confidence, they can now learn difficult concepts much more quickly, and they can start having those what have you eureka moments and ideas and so on much faster, right. So I think it is both the process of knowledge dissemination, making it simpler, also has a salient effect on how quickly somebody can build confidence and therefore go on the journey of research, right.
May I maybe ask you here just with an anecdote, how do you vision this? Like, let's take an example of an engineering student who come from a tier 3 city in an affiliate institution, and how this kind of facilitation would help that student reach the quality and opportunities that an IIT Delhi student might have.
Yeah, so I think it is there is latent potential in everyone, right. It is just that how do we unlock that potential, and how do they themselves discover their potential. That is the real goal, right. So now I can give you my own personal anecdote. See, when I was a graduate student, I just went after IIT, I went to Ohio State, and I got a travel grant to go to my first conference, right. And everybody was saying this conference is so difficult, you never publish. I mean, you get all kinds of negative stories, right. But then when you go and see the papers published and say, oh, I can do this. So the moment you realize that, then immediately your confidence is there, and then the rest is history. You are able to be productive in your research field, right. So similarly, we want to help people, especially in that early stage. So that student that you talked about, right. Now today they have access to all the NPTEL's content, they have the content, ChatGPT or other things are open now, many things are there on YouTube, so they have more broader content. So they don't have to listen to anybody who says negative stuff. They can start learning things, they have the top courses available and so on, right. And then, but the usual thing is, how do you bring it to a simple form for them, right. How do you simple and personalize it for their context. Now then the next question is, what do I work on, what is the interesting problems. Now they may not be exposed to the kinds of problems. So I think we should also be creating problem banks where people who are closer to the problems, now that could be people from industry, it could be people who are NGOs who are close to the problems, we'd like to have problem banks. And now problem is nothing but a knowledge statement, right. Now AI can actually expand those knowledge statements, add more context. So we believe that one is translating some knowledge to another knowledge, the other is to give human expand the understanding as well as have a knowledge bank that we can create, and then we can use AI to connect mentors and mentees together. You have the wonderful Manthan platform as well, so we want to build on top of that. So we need to bring all these things together, and we are thinking of something called Anusandhan community platform that can broaden all of these things and bring some of these things together, right? And also how do we open up science for publishing? We have many such thoughts, but all of these are elements of helping and putting that person in center and helping them go through their journey, right? And similarly facilitating and so on, build around them, empower them. Similarly, once you get to some stage, we will have more opportunities where they can get a fellowship or a grant, where they can go spend some more time, do an internship, and get faster on that journey, right? So yeah,
absolutely. No, that's very helpful to relate to people who are going to listen to this conversation. Now in the next segment, AI also could be used for accelerating the discovery pace that we are doing, even in high-end institutions, like that we have something that we have it globally seen now. How do you see for Indian research community and faculty members in institutions to have AI tools and techniques that are going to be facilitated to accelerate the pace of discovery for them?
See, many of the commercial AI tools and many of them also have free tiers and so on, they have something called a research mode. Okay, so see, today in AI there is one thing called training, and then there is something called inference. Okay, in the training or pre-training you would have trained up an AI with lots of knowledge, right? And then inference is nothing but you ask a question and you get an answer. So now there is one realization that during inference, rather than immediately giving you an answer, suppose you think a little bit more and give an answer. In other words, you spend a little bit more inference time compute and then balance it with training time compute, you can get better answers. So that thought has led to different models from different companies that are again rapidly growing. Those are called research mode. Okay, that research mode says that you give me a problem, and rather than giving you a quick thing, I will take 10-15 minutes and then come back with a much more reasoned this thing, right? So if you are thinking about writing a paper, you want to do related work survey. So this is a great way to do related work survey, right? But at the same time, based on that, you can ask follow-up questions. The human should guide the whole process so that it gets to the right conclusion and use their judgment, right? That cannot be substituted by any AI system, right? So I think this can help accelerate some of the drudgery that humans face, or you may not have access to some specific things, and with the ONOS and all these other things, right? In principle, one can have an AI that can complement all these resources and make it faster to both discover the right related work and then put it all together. Or even if I tell you that, hey, these are the papers, then you can go to ONOS and pick that subscription out, and then you can read it and so on and so forth, right? So the entire process of understanding what to do and therefore iterating that can be faster, right? So all of this is ultimately a knowledge and discovery process. So there are a new set of tools that are emerging for that, right? AI is sort of integrated into this, right? So there are agents and this and that. There are a lot of buzzwords in this, you should think, but the fundamental is the process of discovery itself is a knowledge intensive process. So any knowledge intensive process can be accelerated through AI. That is the basic idea. Yeah.
Now on the other aspect of large scale systems modeling, and also the digital twins that you have very extensively spoken about, how digital twins for computing systems, engineering systems and scientific systems can also be explored through these kind of new ideas. Could you talk a little more about it? Yeah.
So I think you touch upon a very important topic, which is how can science and engineering now be directly modeled in AI. Okay, what I mean by that is, suppose you have Newton's equation, right, like F is equal to ma, right, or some Navier-Stokes equation for sort of fluid dynamics and things like that, right, fluid flows and so on. Now all of these things earlier you will talk about them, you will write English about them, and then AI will try to understand the English and try to reason about it. But what if I take that equation, the partial differential equation itself, okay, and the way we solve it is we do some operators and we solve it, right? So those sorts of things. Now it turns out that neural networks are not just function approximators. Recently it was discovered that neural networks can also be operator approximators. What that means is that I can now do something called neural operators. Okay, so neural operators, of course there are specific types called Fourier neural operators. Okay, so there are some classes like this, Laplace neural operators, this and that, right? So but there is a whole class that are emerging where you can model how partial differential equation can be solved. Okay, or the steps of solving that, and now that becomes a forward pass in your neural network. Okay, forward pass means it's like an inference, right? So typically you give an input, you get an output, which means it's very fast. Okay, and this, if you compare to how we do it today, you take say Navier-Stokes equations, then you would model it in some numerical method, and then you would have some mesh size. You would run it on a high performance computing platform, which is what you talked about, the large compute, right? So if you want to say design a car, okay, or the body of a car, let's say a Tesla car or a Jaguar car or something like that, right? Or if you want to design a wind turbines blade or a airplane's wing, right? Or if you want to design the next generation fighter aircraft, or if you want to design a ship's thing, right? Those designs today, what you do is you design that through CAD CAM, or you design that, and then you do many of these simulations, and each of these numerical simulations take a lot of time. And if I want to do finer and finer mesh, it will take even more time. So now what you can do is, now rather than doing a numerical simulation, you can do what are called AI simulations. Remember that I have modeled the same thing, I am able to solve those equations through AI directly. And then now the interesting thing is that those AI solutions are much faster, not 10% faster. It is 10,000 times faster. Okay, so it's like 3, 4, 5 orders of magnitude faster. Sometimes people have also shown it can be a million times faster. Now, once something you are doing, which would used to take days or months, you can do it in seconds. Imagine what happens, right? Now, of course, there's an approximation error. Let's keep that aside. It means two things, right? When you can do something faster, it means you can do many of them. That's number one. Second is you can put that in real time. Okay. Now, typically today you model a car, but you don't put that model of a car, which is a digital twin, in the car itself. But tomorrow you can put a small GPU in the car, put a digital twin that is directly modeling the car's behavior as the actually airflow is hitting it, and then you can figure out how to optimize the car. So there you might get 10 or 20% better performance, right? Similarly, if you're having a wind turbine and a blade and you're doing these yaw and other rotations and modeling this, so you can actually have in situ or this thing, right, digital twins, and we can make these open digital twins also over time, right? Similarly, you can have a model of an engine, you can have a model of a compressor, you can have a model of a hydrogen electrolyzer. Okay, so every engineering artifact that is a subsystem or a component of a larger thing, you might have a model of a laser and so on, right? All these fundamental things we can build open models, right? So think of you can have base science models of F is equal to ma, base science model, then base engineering models, and then other things. So you can have a stack. This looks like an India stack, right? So now we can have an India stack of open models, and then if you have an environment and plug and play. Now if you have now a new startup that comes, right? Now they want to design a new plane, let's say an E-plane or some electric plane or some new thing which can lift you up and go here, and then you avoid the Delhi traffic and get to the other side, right? So if you want to design a low cost plane of something and you want to design some new materials for it, all of this, right, material science, chemistry, physics, biology, all of these can be more directly modeled, and that is the revolution that is going to come. Science stack or a science and engineering stack, exactly. So that is happening right now, but not too many people know about it. Okay, now that's a new dimension of AI, which is.
This sounds very exciting. I mean, if we visualize this, what you just said, I think it helps in many ways to even provide access to some of the large scale systems that we as Indian researchers don't have access to as of today.
So I think we have leapfrog opportunities, right? Just like when we had the mobile phone, we didn't have to wait for the landline phone to get fully rolled out, we leapfrogged, right? Similarly, when you have these new AI tools and it becomes more accessible, you can leapfrog. Now scientists, what is going to happen whether we are going to participate or not is that science is going to get revolutionized. How we do science is going to get revolutionized. Now the opportunity for India is to leapfrog, right? So we, the best way to leapfrog is to do it. So ANRF intends to support India to just do it, right?
No, absolutely. No, this part is very exciting. Even, I mean, this is kind of eye-opening in terms of not understanding so far what it meant, but now getting to understand what it will actually do. How do you see this coming into reality? Is there any programs thought out or missions thought out?
Yes, I think currently we are at the threshold of launching a new mission mode program called AI for Science and Engineering, which is apropos the topic here. So where we are thinking of running it in a very different way also. We want to have an open source, a national open source program, which will be the first time in the world where anybody has run a national open source program. Okay, and that as part of that, we want new models to be built, okay, and then we are going to be also working to create or make new data sets available, Of course, we are partnering with the India AI mission as per we are integral partners on this whole journey, and of course other departments, DST, MOES, DBT, DHR, all of them are along with us, as well as DRDO, NRB. So we hope to see more partnerships with the departments and external partners as well. So I think the goal there is one is to build a stack, like you said, of open source models. The second is there may be a lot more advanced models in specific areas, all the way from astrophysics to defense, it will be in particular domains, right? It will be in, say, how do I accelerate some aspects of biology, or say enzyme design, or it could be in cell and gene therapy, some building blocks of that and so on. So that will be the next stage. And then the third stage would be how do I take it to some vertical and deliver value, right? How do I accelerate the loop of science?
Applicability of
it. For example, if I can do these things fast, how do I reimagine how HPC is done? How do I reimagine how CAD is done? How can new startups form there and so on? And then how can I even do online experimentation that can complement real world experimentation? How do I do experiment design? So I think the entire loop of science can get changed. Okay, so we are going to be supporting various initiatives that can, or various initiative projects that push the boundaries of how to do this. And hopefully India will come out as a leader in all of this. Right?
Absolutely, yeah. No, when it comes to the ecosystem that is going to benefit from such initiatives, where do you see our deep tech startups come into play? Do you also have some thought on how they can be plugged into these kind of activities?
Look, I think in general, right, so when you take deep tech startup, right, so somebody is actually having a long journey of doing many experimentations, getting their products and going, right. So what we want to do is to help accelerate that process. So all the technologies that we will build, hopefully as part of this initiative, could help the journey from deep science to deep tech be much faster. Okay, that is one of the goals. One of the characteristics of deep tech is a very long, requires a lot of investment capital, a lot of experimentation and so on, right. So maybe as we convert more into computation and convert more of the computation to AI, maybe we can shorten this cycle. Okay, so that is one of the hopes of the program. But in general, as we are going forward in various of our programs, especially the mission mode programs, the ANRF is liberalizing progressively, so that we can have both academia, national research labs, and startups and industry, MSMEs and so on, come together. Now, and our funding can also go to startups and MSMEs for sure. Now, industry has to, larger industry has to bring in capital for our mission mode programs, but of course our RDI is a different vehicle where we directly fund industry. Yeah, so but think of our base programs as supporting academia and research labs, where industry and other partners are welcome to participate and be honorary PIs and things like that, and take advantage of our funding and be there in the early stages. And of course they are welcome to do other things as well. Now this mission mode is where we are starting to directly involve some of these entities. And remember, we talk a lot about industry academic collaboration. So these are places where industry academic collaboration can come together, and then they can work towards an outcome, right? And then it will build the habit of delivering outcomes. It will build the habit of going beyond papers and patents and towards mission mode outcomes. And then if you do a bunch of these, and then that leads to RDI, which is a much more focused thing. So I think from a deep tech perspective, it's a wonderful place to be in, because each of these verticals, there are different verticals, and over time ANRF will be investing in many of them. And we just talked about AI as one of the more broad-based vertical, but directionally that's where we are going, but we will be slowly liberalizing more.
Great. Just to dig little deeper into the aspect of, let's say, the modules getting built, the open source modules for the AI system that is getting built. If somebody to ask who will build that model, will there be like a funding program to build that model, or is it like again a redistributed system where anybody could build it and contribute to that common source of open source models in the country?
Yeah, look, India has one of the largest developer ecosystems, and also India is either number one or number two users of AI systems like ChatGPT and so on, right? So that's a great combination. And our university ecosystem is a place where we have a thriving set of young users as well as young builders that are emerging, right? So when we are talking about an open source or a national open source, we will run contests. Okay, now there are different ways of running it, like Kaggle contests and other things, but we will define a contest and say, okay, this is a challenge I'll give you. Okay, this is some data set. Okay, build a model. Okay, and we will say this is the type of model I'm expecting. Okay, and then whoever builds a model gets a prize. Okay, of course we will provide GPU resources and so on, so that the model can be built, etc. Working with MIT and the India AI program. but then those models will be contribute to the world. It becomes part of the world's public goods. Okay, and of course, we'll have the right broad-based licensing terms that are state of the art for open source and all that. So India is going to now create a lot of public goods for the world, and of course we are benefiting from the public goods like open source from others, and hopefully this will become more of a coherent set of things that we can offer back to the world. And if we do it right and it really takes off, then the ordinary students that are contributing to this, they will become the champions of the future, and they will redefine how science is done. Absolutely. Not just for India but for the world.
Yeah, so it is going to be a collaborative model in which it is developed. Yeah. Now an important segment on this topic itself, the academic ethics. So already in the realm of digital publishing, predatory journals and all of those, and the data sharing and all the aspects that we link to who uses whose data and how it is used, how it is manipulated, there is a question of ethics. There are academic ethic policies at the national level, at institutional level and stuff. When AI comes into play and when we use these systems, how do you see ethics and academic ethics come together, and what kind of terms and references we should have in place?
This is a very important area and we are all learning to it. I would be remiss if I said that I knew all the answers. Okay, so it is an area we are also learning through. We do have ethics guidelines, we have sort of an ethical undertaking that all our projects have to take on. Okay, so that is as part of our granting process itself. And in general our direction is towards quality, not just quantity, right. And so I think all our measurements, and there are more reforms coming in the way rankings are done, which also disincentivizes just going after numbers and and hopefully that will disincentivize bad behaviors of various kinds, right. So that is one aspect. But then when you talk about AI ethics, now of course the AI is known to have biases, AI is known to have some other challenges, but look, any tool will have its own limitations, right. If you take a scissors or if you take a knife, all of them will have its own pros and cons, and of course it is important to shine a spotlight on some of these things, and then that will lead to new areas. But I should also point out that just yesterday we have announced a new program for centers for social sciences and humanities at the interface, multidisciplinary, at the intersection of science and technology. So we are hoping that there may be centers which can study such kinds of things, which people who come from more of a technology background like myself may not be fully aware of, right. But I would say that look, this is going to be a learning journey for us. We have some guidelines in place, we will have more in place, but I think as we are educated by the broader community that is experts on these areas, then we can learn better and we will evolve our guide.
Absolutely. And on the final set that I have, and then I would also ask you to add anything more that we would like to cover here. The KPIs, how do we measure the performances of anything in general? Of course, the digital tools and AI tools have been very handy when it comes to defining KPIs and measuring KPIs. Now here one of the digital tool itself is getting used in something what we call exploratory nature, which is doing science and engineering. How would we define KPIs for that? Are there any thoughts on?
So look, I think it's early days. See, one is okay, we have to ask fundamentally what are we trying to accomplish, right? We are trying to accomplish faster speed of scientific discovery. Maybe new directions of scientific discovery which have been unexplored that we can now do because we can do it faster, better, cheaper, etc. Right. So once you understand or say that this is the broad gambit of what we are trying to do, then you would have appropriate KPIs for that, right. So I would, to be honest, I have not thought through specific KPIs for this process, but I would say that one is, have I accelerated the process? Am I introducing some negative features, some biases or some sort of lazy behaviors or whatever it is, right. So there could be some thing you have to see what is the positives that you are trying to measure, what is the negatives you are trying to measure, or maybe there are some new things that are happening. See, typically when new technology comes, there is also unexpected things that happen. So it is very hard to forecast those sorts of directions. So right now I think KPI is a good question. Okay. So I think let's put a pin on it and continue to progress on it and keep an eye as we go forward.
Absolutely, yeah. No, that's a good point to cover and keep it in our records and then to relook at it later. And a final point from my side.
But if I can add one more thing, in general mission mode programs, we do have to govern towards outcomes. But I look at quality, impact and outcomes as a triangle, right. So these are all closely related ideas. So moving away from quantity to quality, always thinking about impact, always thinking about at least a potential outcome, even though the actual outcome might be different from what you had planned for, right. I think that mindset is very important, right, and then governing towards that is very important, and therefore what it means is you cannot have a fund and forget model or sort of then give some money and then yank it back model on the so you have to have a mentoring oriented model, but as you learn whether you have a positive outcome or a negative outcome, how do you adapt, okay. So what matters is the rate of learning and the rate of adaptation. So whether you talk about fail fast or all of these things, what really matters is not about you succeed fast or fail fast, but how many cycles you are able to do and how much learning you get and how you are adapting, right. So then how we can coach or adapt towards that entire process, that is what matters. So we are trying to think through our governance process to be more aligned to this, right. So that is the only addition I would say.
No, great, and that certainly adds context to our conversation. The final point I had was about one is the recipients of, let's say, the public money and the programs, and then they use AI for doing science and engineering, that we covered. From the research governance and research administration point of view, will there be AI tools used in terms of selecting projects, setting up proposals, setting priorities and stuff? Will there be any provisions?
Yeah, it's a very interesting question. So we've been thinking about what role can AI play, right, in the whole process, okay. So on one hand it is very tempting to say AI can quickly read your proposal and it can come up with the scores, right. So then, oh, why do you need the human and all of that kind of stuff, you can have that. But then imagine you are somebody who is writing a proposal and then you get back and say your proposal was rejected by AI. That is not a good idea, right. So I think we have to balance these two perspectives. So so right now we are treading here a bit carefully. So we know that tools can be used to generate what we call reference reviews. We also know that some of these reference reviews can be used in different ways. Now we have two ideas. One is that let the committees that normally do the evaluation do their standard evaluation, but then you can also have reference reviews from AI or even multiple AIs for that matter available parallelly. Now if the decision process of humans leads to somewhere where good proposals that the AI thinks it's good but the humans reject it, or the AI thinks that's bad but the humans accept it, right. So those outliers you could have a second look, okay. So this is one way of integrating AI into the process. The other, at the so where you're not actually you're just using it as a checks and balances for outliers, so that good proposals or really bad proposals don't get in, or a good proposal gets funded, bad proposal, or at least you get a second look, right. There should be really good reasons for them to be thrown out and so on. So that's one track. The other is when people are writing reviews, you could write a review, but then your review can be potentially enhanced with AI and so on. So there can be some enhancement during the reviewing process, because there's a lot of reviews. Just to get a sense, we have thousands of proposals that are coming to us. So we have to definitely there's a huge human load on managing that. So AI could perhaps play a role. Now again, we are being careful in how we construct this role, because again there are many reviewers and we have to do this. So I would say the short answer is we are looking into it, but we have not yet made any decisions on its use.
Perfect. That's all from my side, and anything else that you would like to add with respect to AI for science and engineering, we'll be happy to cover.
See, first, as I said, this science and engineering and modeling of science, right, is an extremely new area. It is going to completely transform how science is done, okay, and also the entire process of using research and discovery, where AI can potentially make an own discovery on its own, or a human plus AI together can make discoveries faster or prove theorems, or any of these sorts of areas, or where there are large data sets that are unexplored, like astronomical or astrophysics data sets and so on, you could make discoveries faster and so on, right. So there is a lot of discoveries waiting to happen. So I think we are in a threshold at which science itself can be accelerated. Second, the process of science to impact can be accelerated. So that is, once some science has been built, now you can quickly model it in AI, you can now quickly scale it and now it can be part of a digital twin which can then quickly go to a product, right. So the deep science to deep sec I think can be accelerated. Now on that you add up these other tools for better research or faster knowledge dissemination through the ideas of Saril and other things. Now you can do the same thing with patents, not just papers, right. You can take a patent, then you can hypothesize what are the product opportunities. So then that can potentially help accelerate the technology transfer process.
Any innovator who looks into it, it eases their process.
Eases the process. It can go both ways, right. You can look at product market fit hypotheses. Similarly, somebody who's scanning for technologies can find you know, patents that are interesting, you know, by looking at patent databases much faster and so on, right. So all of these are possibilities. Now of course you know, we think that some building blocks needs, or like a jigsaw puzzle, building blocks need to be made. But how that jigsaw puzzle is going to be coming together is anybody's guess, right. So we think it is a you know, exciting area for the future, and I would urge people to think that there is always a talk about AI taking away jobs. I feel the right dialogue is how can we get empowered with AI so that we can do new things, more things, different things. Okay, with that I think whether it's science or whether it's any other part of life, I think we can empower 1 billion people with AI. We can empower scientists with AI, we can empower that student you talked about so that they can go in their journey faster or do things they were not able to do, right. I think that story of AI for empowerment of science is a good note to end on. Okay.
I'm going to change the title of this piece to AI for empowering science and engineering. So with that, thank you so much Dr. Shiv. It's been an amazing having this chat with you, and we'll also continue this conversation in further other avenues, and with that again thank you so much.
Thank you so much, Chagun, and really thanks to the PSC.